All right, so here we go. Find the line of reflection. I always like graphing this, and you'll see why when I start doing the problem. So let me throw the graph up of these 2 points. Not needed, but I like it. All right, so I have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That is D prime. And I'm also 1, 2, 3, 1, 2. There's the point I start with. All right, so now I'm looking for the line of reflection. And remember, the line of reflection is the same thing as if I connect D prime, I make a segment. The line of reflection is the same thing as the perpendicular bisector for D prime. All right, so I need help writing the equation of the perpendicular bisector for this. All right, so let me take care of the perpendicular part first. I'm going to have to do slopes, right? Perpendicular lines have slopes that are negative reciprocals. First thing I'll find, and this is exactly why I graphed it, let's find the slope of D prime. You can do it one of two ways. You can plug in the coordinates to y2 minus y1 over x2 minus x1. Or, this is why I graphed it, you could also do rise over run. So as I look at D prime, I'm going up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. 6 over 4, but you just got to pay attention here. See how it's going downhill from D to D prime? If it's going downhill left to right, I got to remember this is a negative slope. So the slope of D prime, negative 6 over 4. If you prefer, I do, if you prefer, you can reduce it just so you're working with smaller numbers. So negative 3/2 is my slope. So that would mean the slope of my line of reflection, because they're perpendicular, it has to be the negative reciprocal of negative 3/2. Flip it, change the sign, positive 2/3. So there's the slope of my line of reflection. Next thing is, all right, I got the slope. How about that y-intercept? All right, how about that y-intercept? So usually, this is the way we've been doing it in class all year. To find the y-intercept, I plug a y coordinate in for y. I plug my m in, my slope in for m. I plug in an x coordinate in for x, and I solve for b. Well, the only thing I know right now is the m, 2/3. What I need to find, and I need your help with, is can you help me find a point on the line of reflection? Find a point on the line of reflection so I can plug it in for x and y. Oh boy, oh, how am I going to find a point on the line I don't even know the equation of yet? Well, remember, it's a perpendicular bisector. It bisects D and D prime. So I know for a fact that the line of reflection has to go through the what of D and D prime if it's going to bisect it?
Midpoint?
Midpoint. The midpoint will be a point on the line of reflection. So I need to get out midpoint formula and find the midpoint of D prime. All right, review of the midpoint formula. Let me just go back to those coordinates. Add your x's. So 7 plus 3 over 2. And then negative 4 plus 2 over 2. So that gives me 5, negative 1. 5, negative 1 is the midpoint. That's the x and the y I need to plug into y equals mx plus b. So let's do that now. The y is going to be negative 1. Slope was already found, 2/3. X was 5 plus the b. Negative 1 equals, and I don't feel any sympathy for you guys. You have calculators that can handle this. 2/3 times 5 is 10/3 plus b. Move the 10/3 over by subtracting it. Again, you can just go right in your calculator. So it looks like my y-intercept is negative 13/3. All right, perfect. I have everything I need now. So my line of reflection is going to be y equals 2/3 x minus 13/3. Okay. So line of reflection is the same as the perpendicular bisector. You take care of the perpendicular part by finding the negative reciprocal of the slope, and you take care of the bisector part by taking the midpoint and plugging it into y equals mx plus b to find your y-intercept. All right, there you go, guys. Next up, other questions from the packet, questions in general. I'll answer anything I can.
Can you go over 27?
All righty. Alrighty. It says that we have just performed a rotation. So going through my mind right now, that's great that it was counterclockwise and around x. That doesn't matter in the problem. It's the fact that I rotated. I know two things right now because I've rotated. Angles are congruent, corresponding angles are congruent, and side length are congruent. Because remember, a rotation is a rigid motion, which preserves distance and angle measure. That's important because now that I know I did a rotation, I need to figure out what angles and sides match up. Don't look at the diagram. Please don't look at the diagram and try to figure out what sides or angles matched up. They tell you right in the directions. Triangle ABC maps onto triangle RST. Right away, because the order of the letters matters, I know A is congruent to R. I know B is congruent to S. Sorry. I know C is congruent to T. All right, that's just because the placement of the letters in both triangle ABC and RST. And then which statement must be true? A is to be congruent to R. And if you look at any of the sides, CB should be matched up to ST, not TR. And CA should be matched up to RT, not TS. All right, and again, I'm not even looking at the diagram. The letters, as you guys learned from our when we started proofs, order matters, how they write the letters of the triangles. They tell you what angles and sides match up. All right? Others, let's keep it rolling. Excuse me. There's some challenging ones on that packet, no doubt. Ask as many questions as you guys need. Doesn't matter.
Could we go over opposite and same orientation?
You got it. All right, so let's say I have triangle ABC I do something to it, right? I do some type of transformation. I'm not going to say what. And I end up with this triangle here. Let's see, C prime, B prime, A prime. All right. So from here, you have to decide what order you want to go in. All right. I can go ABC, CBA, ACB, whatever order you want to go. So I'll just be a classic and go ABC. So as I go from vertex A to B, B to C, C to A, I am going in a clockwise orientation, clockwise, in a clockwise direction. Now, because I went A to B to C back to A, I may have to make sure I go in that same letter order when I test out the image and what orientation it has. So now I'm going A to B, B to C, C back to A. Notice what I did there. That is counterclockwise. So what we would say is these two figures have opposite orientation. All right, one's going clockwise, the other's going counterclockwise. If they were both going the same direction, I'd say they have same orientation instead. Now go back to the opposite orientation that I have up here. There are only two transformations that result in the two figures having opposite orientation. One is a line reflection. And the other is a glide reflection, because part of a glide reflection is reflecting over a line. So these are the only two that would cause two figures to have opposite orientation. All right, everything else, rotations, translations, dilations, they would have same orientation. Just make sure, again, whatever letter order you pick, it's the same for both figures. All right. Whew. What else you guys got for me here?
For using the distance formula with one of the problems, is it like gonna be?
It is.
Like
sorry.
problem?
No, it's very similar to what we did in class with dilations, where I give you, for instance, I'll give you, line segment CD has this coordinates. It's dilated by 3. What's the length of A prime, C prime, D prime? Something like that, sir. I'm not saying it's exactly like that. I don't want to say that. And then you guys read the problem. You're like, this was different than what you said in the review. But it's along those lines of the dilation problem we did in class. Where else here, kids?
Can you go over the glide reflection?
Sure. Okay, so I'll get back triangle ABC. All right, remember a glide reflection is just equivalent. It's the same as doing a translation and the line reflection, with a little catch though. All right, so let's say I have triangle ABC. I'm going to reflect it over this line here. I'll call it line L. Okay, so I'll do the reflection first. So here we go. I reflect over line L. Here's triangle A prime, B prime, C prime. All right, so there's my reflection. Now, to be considered a glide reflection, the translation part of this, I need to translate slide, thank you, translate slide parallel to the line I reflected over. So because I reflected over line L, I really can only go slide this way or slide to the left. If I try to slide up or down, that's not going to be parallel to L, and that would not be a glide reflection. So the translation must be parallel to whatever line I reflect over. Okay, so there's only certain options I have for the translation part. It's got to be parallel to whatever line I reflected over. So that is a glide reflection. And the order doesn't matter either. I could have done the sliding, the translation first, as long as I reflected over a line that was parallel to that slide.
Are glide reflections always done reflection and then translation, or is there like a order?
No, order doesn't matter. You could translate first, then reflect second. Again, just as long as whenever the slide occurred, first or second, it was parallel to the line you reflected over.
Will we ever have to do one over a horizontal line?
What do you mean a horizontal line?
Like if it's on a graph and we would do them reflected over the Y or X axis,
Yep.
would it be something, could you do it over not a diagonal line, sorry.
I wouldn't have you do it on a graph on a diagonal line. That would probably more just be like a diagram type. The only thing probably that I expect you to do as far as a glide reflection on a graph would be a horizontal or a vertical line, not a diagonal though. Because that would be too tough to tell if you were sliding parallel or not. What else, guys? Let me take a look at invariant point. Sure, points that don't move. All right, I perform a transformation. So let's just say, I don't know, I got point A is 3, 2. I have point B is 0, 5. I have point C, which is, I don't know, negative 6, 2. And I have point D, which is negative 3, 0. Not D prime, sorry, just D. All right, so here's the question I have for you guys. If I do the following, let's say I reflect over the y-axis, which point up here will remain invariant? If I reflect all 4 points over the y-axis, which one of these points is going to remain invariant?
D.
Where's negative 3, 0 located?
Oh, sorry, B.
Right, that's negative 3 zeros on the x-axis, so it would move. B, yes, B is located on the y-axis, so B would not move. Correct. What about this? Let's say I reflected through the line y equals 2. The horizontal line y equals 2. What points would not move now?
A and C.
A and C, yep, exactly. Okay, so those are points after I perform the transformation that just don't move at all. They just stay there. Let's see, what else? Somebody already asked about orientation. That'll be on there. Compositions, remember, done right to left. All right, I will ask you to do a composition on this test, so make sure you do the right one first, followed by going to the left. We talked distance formula already. We talked finding the line of reflection. Also, just remember, anytime you do any rigid motion, rotations, translations, or reflections Number 1, angle measure is preserved. So the corresponding angles in the figures are congruent. And side length is preserved. So corresponding sides are congruent. I don't know what's going on with my pen here. All right, so just keep that in mind. May help you answer a question or two. Okay, one other thing I want to go over, and I know I'm just going over this just because I did yesterday in our review too after school, so I just want to keep it fair. Let's say let me get my regular pentagon out right now. My regular pentagon. Okay, here's my regular pentagon. What I would like to know is, can you find the minimum amount of degrees it would take to carry this pentagon onto itself? Meaning, the pentagon you see up in the screen right now, what's the minimum amount of degrees I could rotate it and get this same pentagon in the same position back? That looks exactly like this. Not tilted a little bit to the right or left, but looks exactly like that. 360 is a good answer, but I'm looking for the minimum amount. There's a lot smaller degree measure I could rotate. Now, if I go from point B and go to every vertice until I get back to point B, I've gone 360 degrees. How many rotations would that take for me to go all the way around?
5.
5, right? 5 sides in a pentagon, 5 rotations to go 360 degrees. So I take 360 divided by 5. That tells me every time you go vertice to vertice, you're going 72 degrees. So that would be the minimum amount of degrees it would take to get this same looking pentagon back, 72 degrees. Let me change the question. Let me take the word minimum out now. And it's just a multiple choice question that says, how many degrees would it take for this regular pentagon to carry it onto itself? And maybe 72 isn't there and 360 isn't there. What do we do now? Well, all right, 72. Maybe I want to go from B to E. And there's another 72 for 144 degrees. Maybe that's not a choice. Maybe I keep adding 72 till I find the choice I need. All right, so just because the minimum amount isn't there doesn't mean I can't still carry it onto itself. All right, I just keep adding 72 to it until I find a correct choice.
When you're doing a question like number 30 in the packet where it's asking you to describe the sequence of transformations, do you have to specify which one you're doing the transformations to?
Do you mean figure to figure?
Yeah.
Yeah, absolutely. Yeah. Like you have to say ABC undergoes a transformation of ... DEF undergoes a transformation of, because if you don't, say it's a translation, all right, and you go from, and you don't specify a translation, like say you put -3, 2, well, which figure are you doing that to? Because one of them is going to be correct and the other one would be the opposite. You know, if you go from one triangle to the other, it would be to the right 3 down 2. So yes, you do have to specify which one you're starting out by transforming. Absolutely. Yep. And I'll be honest, some of your classmates started with the wrong triangle or just did the opposite where they should have done today. I'll just leave it at that. So yes, tell me what triangle is being transformed. Good question there. Others you want to go over, guys? Anything else here? Ask away. Nothing else? Come on now. Thought you guys were going to be peppering me with questions. I'll have to wait to the next unit for that one. Oh, baby. Enjoy this transformation unit. Nothing else, guys? And I gave you everything I could on the test there, so I gave you whatever I could to help you guys out. You guys know the deal. If something comes up tonight, shoot me an email. Be more than happy to answer you guys. All right, so take your time tomorrow. You'll be fine. People have been doing a decent job so far. I've corrected a couple of them from first period, and they've been doing fine. So I don't see any reason why you guys shouldn't either. All right. All right, guys. Thanks for coming to the review. I will see most of you tomorrow in class. If not, you guys do a nice job on formative for me tomorrow. All right. Bye.
Thanks, have a nice day.
You too.
Mr. Colin,
Yes, Peter.
can I just, what do you mean by like a for composition part A, the two parallel lines, the two intersecting lines? What do you
Yep.
mean?
If you, like a composition means you're going to do two or more transformations. And what I mean by two parallel lines is, all right, I have two parallel lines. If I ask you to take a figure, like take triangle ABC here, and I want you to reflect it, I'll call this line L and this line M, and I want you to reflect it over both lines right now. So I reflect it over L. There's C prime, B prime, A prime. Then reflect it over M. I have A double prime, B double prime, C double prime. What I'm asking is, what single transformation could have taken ABC all the way to A double prime, B double prime, C double prime? And that would be a translation, a slide over. So anytime you reflect over two parallel lines, you end up with a translation.
Okay.
And then if the lines intersected, anytime you reflect over two intersecting lines in a row, you end up with a rotation.
Okay.
All right, that's what I meant by that. So
Okay, thank you.
you're welcome, Peter. Hey, Andre, how we doing? Good, thanks.